Hello guys, welcome to the second video of the Hedge engine series. Today I'm going to talk about Cubemap. First, why did I want to spend time researching Cubemap? Because it's the base of lots of features in the game engine like skybox, environment light, and the reflection probe. In addition, I want to use a Vulkan feature called multi-wheel to generate Cubemap, which is an extension that I'm interested in, so I spent some time on investigating relevant concepts and made a Cubemap generator and renderer in Vulkan. So today's video structure is relatively simple. We'll talk about the basic theory of Cubemap first, then we will talk about how I captured the Cubemap. Finally, the Cubemap renderer will be explained. First, let's take a look at what is a Cubemap. According to my research, the Cubemap originates from this ancient article. The basic idea of the Cubemap is simple. You have a perspective camera and you use this camera to capture the 6 directions. Besides, both of the vertical and horizontal field of views are 90 degrees. Then let's look at the theory of turning a panorama to a Cubemap. Is described in this article. Further details on deriving Cubemaps from inquired rectangular images. So in this section, the author introduced how to rotate the camera to capture the 6 surrounding directions. Then the mapping algorithm is introduced. We need to note that the author assumes a 2x2x2 cube here, so the point y coordinate is 1. Well, let's take a closer look at these steps. First, we need to set up the camera and let it watch along the positive y-axis, which is the starting direction. Second, we need to project the screen space point to the cube's front face. Third, the point projected on the front face is rotated to the desired face by applying a rotation matrix. Fourth, we need to calculate the longitude and latitude. It looks a little bit complicated, but it's not hard to derive after some drawings. This is also why the author assumes a 2x2x2 cube, which can make the derivation easier. Fifth, we need to map the longitude and latitude to UV texture coordinate and use the UV to sample the panorama for each pixel. Hello guys. So let's take a look at the GLSL code here. So is the fragment shader for the pipeline to sample the panorama and generate the Cubemap, or specifically to generate the 6 faces of 6 different directions. So yeah, let's take a look at the code. So first we can see the panorama texture is an HDRI texture, and we also pass the scene information into the shader. So the first element is the rotation matrices, as you can see. So we use different rotation matrices to rotate the camera, and we also pass the width and the height of the screen, so we can use them to generate our screen space coordinate. So yeah, and the third one is our wheel ID. So here I use an extension of Vulkan called wheel instancing. Or I'm sorry, it's multi-wheel in Vulkan, and in DirectX it's called wheel instancing, but they are the same thing. It basically means you can call the draws with the count of wheel in the parameter. So for each draw, it can feed a wheel ID into your shaders. So for example, the first draw would get the ID 0, and the second draw would get the ID 1, and so on. So yeah, but under the hood, at least for AMD, is just repeatedly draw the things. Yeah, so then let's take a look at how do we get the screen space coordinate. So we use a built-in variable called glfrag coordinate. Is in the unit of pixels. So as you can imagine, it'd be super big, and that's why we need the width and height of the screen, and they are also in the unit of pixels, so we can map this coordinate to -1 to 1, because that's what we want. That's what mentioned in the paper. And yeah, here we get the rotation matrix by feeding a wheel ID into it, and by applying the rotation matrix to the original point P, as you can see, is y is 1, so it means it's on the front face, right? And yeah, we get the point after rotation, so it may be at right, maybe at top, and it's also possible that it's still at the front. And yeah, but from the point P, or from the point P prime, we can get longitude and latitude. It's just in the spherical coordinate system. You can get them from all kinds of arctangent functions. And I want to mention this one. It is a little bit different from the paper. So in the paper, it uses the right as the starting place for your longitude, but for me, I prefer to use the forward axis as the starting point for the longitude. Anyway, so by following the same algorithm, we can get I and J. So the answer uses I and J to derive the UV coordinate. And yes, quite straightforward. Afterward, we use the UV coordinate to sample the panorama HDRI, and we get a color for the pixel, and finally we output it. Yeah, so overall it's a quite straightforward algorithm. To be clear, a Cubemap is sampled by a 3D vector. So until now we have gotten the 6 faces to fill a cube map, but they cannot be simply copied and pasted into the 6 layers in Vulkan, because their edges cannot match each other's. Why? Because Vulkan has its own unique Cubemap sampling algorithm. Let's take a look at Vulkan's document. First, after getting a 3D vector, the Vulkan uses it to select a face first. For example, in this coordinate system, positive x is front, positive z is right, and if we use a 3D vector that has negative z, and the absolute value of this z is larger than both x and y's absolute values, then Vulkan would select the z face. In other words, Vulkan doesn't care about orientation. It only knows x plus or minus, y plus or minus, and z plus or minus faces. So after we select a face, the hardest part comes, which is sampling. The Vulkan uses the 3D vector to generate ST to sample the selected face. However, we stored information in UV, so we need to massage the original faces to generate new faces that can be directly put into the Cubemap texture. So I spent some time on the derivation, and I found that we only need to try to remap UV to ST in the illustration below. As a result, we have the following conclusions. First, of course, we need to capture 6 faces, as we have mentioned at the beginning. Second, we need to flip the U for the front, back, left, and right textures. As for the top face, we need to swap its U and V coordinate. And for the bottom face, we need to swap its UV first and then flip both its U and V. By the way, as for flip, we mean 1 minus a coordinate. Like if we say that we want to flip U, we mean the new U equals to 1 minus the old U. Alright, so finally we have 6 new faces. Then we only need to put them into the Cubemap's 6 layers sequentially. For example, we need to put the front face into the X plus, which is the layer 0, and we put the back face to layer 1, top face to layer 2, bottom face to layer 3, right face to layer 4, and finally the left face to layer 5. So let's take a look at the code. First of all, we can see the input here is an array of textures. They are just 6 faces, front, back, top, bottom, left, and the right. Then we also input the width and height of the screen. They are in the unit of pixels, so we can remap the GL fragment coordinates to the UV coordinates. UV is only 0 to 1. And you can see this is the wheel ID, it's the multi-wheel that I introduced before. So we use this to get the texture. So when the wheel ID is 0, 1, 4, 5, we only get the front, back, left, and right. So according to our conclusion before, we only flip the U. And if the wheel ID is 2, then we get the top face, so we only swap it. And if the wheel ID is 3, we get the bottom face. And yeah, according to our research before, we need to swap it first and then flip both of the UV. So finally, we get the color of the target texture and then use the newly generated UV to sample the texture to get a color after massage and output it. In addition, I also want to mention how did I write my vertex shader. So I didn't really draw a big cube in the scene. I basically draw a big quad that covers the whole screen. So as you can see, it's just a squad and I just output it. So you can just use a command draw to draw 6 points to draw a least triangle, and boom, it works. You can get a quad covers your screen, and after rasterization you get lots of pixels, and these pixels can cover your screen. So let's take a look at our tools and how to use them. So yeah, the first tool that I'm going to introduce is the Cubemap generation tool, and that's what I have introduced until now. Yeah, so here is my GitHub for this project. So the tool is here under this folder. As you can see, I also wrote a README here, and yeah, you can also build it by using the CMake, and here are the GLSLs that I introduced before or explained before. But yeah, if you don't want to build it, I also packaged it here. Oh, I'm sorry, here in the release section. So yeah, you can just download the .exe here. It's written in Vulkan and it uses your Vulkan graphics card driver, so it should be good. And yeah, so I downloaded before. Let's see. Here it is, and yeah, here's the tool, and let's take a look. Let's take a look at its arguments. So it expects a SRC path to the HDRI, and as for HDRI, I recommend you to download HDRI at Polyheaven. So there are lots of interesting and free HDRI, and let's open this. So yeah, here it is. Looks pretty good, and yeah, you can just click here to download, and please be cautious that you should select the HDRI instead of the EXR. The EXR is a compressed format, and HDRI is the original format without any compression. And yeah, currently my tool doesn't support the EXR because it relies on an additional third-party library, and yeah, I still need to write maybe 10 or 20 lines of code to support it, but it's a little bit tedious, you know. So yeah, if you guys want EXR, I can try to support it. And yeah, as for the image, I have also downloaded. So let's come to my download folder. So the name of it is the restplace.hdr. Let's use the tool to generate this Cubemap format. So -- source path, and yeah, currently it only supports the full path. So let's shift right click and copy it as path, and copy it here and enter. So yeah, it says Cubemap saves successfully. It means it's good, and it outputs an HDRI called output Cubemap. Let's open it by using the render doc. So yeah, it looks pretty good, right? So it looks like Cubemap now. So it's the front, back, left, and right, and in the middle we have the top and bottom. Then we want to render it out. So before checking the checking the tool, let's take a look at its code. So yeah, here's the tool, and in the GitHub it corresponds to a sample. So let's go ahead into the samples folder and open the 3.2, which is the PBR environment basic, and it corresponds to this tool. Let's read it. Let's read the fragment shader of it. So yeah, you can see it's basically the algorithm to sample the Cubemap. You can see the first one here is the sample cube, is the sample over cube, is the Cubemap format in the GLSL, and yeah, we just put these 6 images into it and it can generate a Cubemap. Then yeah, as for others, we generate the screen. So we use a pixel's location to generate its world position and then use it as a vector to sample the Cubemap. So yeah, here the wheel direction is the vector, is this 3D vector that we are going to use to sample this Cubemap. So yeah, this is basically the algorithm here, and yeah, there are lots of details to in the Vulkan to link your input and output here and there, and I won't really introduce this. You can just check my code here. Yeah, it's just in the CPP, in the main CPP and the PBR environment basic app CPP. And I also want to mention another thing, that is the reading logic here. So it is so for the application, for this Cubemap rendering application, it is fixed. It is fixed to this string. It means it reads the Cubemap from the data library, the data folder, and it reads the HDRI has this name, which is the Little Paris. But yeah, our generated HDRI is the output Cubemap. I changed it before, so yeah, it will read this HDRI, and I believe I also put that output here. So but let's copy and paste it. Oh, sorry, it's not this one. Yeah, let's copy this one to the Cubemap renderer. Yeah, enter the data folder. Let's delete the old one and copy and paste the new one, and we can run this app. As you can see, now we get the farm scene, and yeah, you can also use the mouse to control your camera. Now I'm using my middle mouse to look around. So yeah, as you can see, everything is good. It's sampled as expected, and you can't see any mismatch between the 6 faces. Okay, so these are all the contents of this video. In my next video, I want to introduce PBR's micro-facet theory and my experiment applications. If they are not long enough, I'll also introduce my image-based lightning experiment applications. So after all these experiments, I'll put the skybox, PBR material, and image-based lightning into my Hedge engine. Alright, I hope you enjoyed today's video, and I'll see you in my next video.